Welcome to the video for Unit 4, Day 3, Adding and Subtracting Polynomials. This video will provide the proficient version of the lesson. If you are not at a proficient level, you should exit out and go back to find either the basic or advanced. Today's lesson is on adding and subtracting polynomials. This is a skill you probably are familiar with from Algebra 1, so we'll just do a quick review. In this case, we are adding two polynomials which are in parentheses, and we're also multiplying the first one by a factor of 2. Your first step is to distribute that 2 and make sure that you distribute it to all three terms. Remember that distributing is just multiplying, so it doesn't change the variable or the exponent. It just changes the coefficient. Okay. The second polynomial is not part of the distribution process. Make sure that you don't multiply the second polynomial because there's no coefficient out front. You'll bring it down just like it is. And then you'll combine like terms. In this case, 2x cubed has no like term, so it stays by itself. Negative 8x squared is like terms with 8x squared, but those two coefficients are opposites, and opposites cancel, which means that there is no x squared term at all. Don't even write the x squared. 5x is by itself, and then 2 and negative 1 are your constants, which combine to be a plus 1 at the end. This is your final simplified version of the polynomial, and you should box your answer. A couple reminders when you're doing this to avoid common mistakes. Make sure that you distribute only to the first parentheses if that's where your coefficient is. Of course, if the coefficient was in the second, you would do only the second. Make sure that you distribute to all three terms in that polynomial, or 4 if there were 4. And remember that if the coefficient of two like terms are opposite numbers, just like 8 and negative 8, then the whole term cancels out. If you feel like you understand this topic, please flip to the back of this page, and in the space for practice problems, solve these 4 example problems. Pause the video here while you solve them. When you press play again, I'll show you the correct answers. Here are the answers for the first 4 practice problems. This is actually number 1 and number 3. And then number 2 and number 4 look like this. If you need more time looking at this, pause the video here. Otherwise, we'll continue with the next example on the front. So instead of giving you another example, I think you actually probably have a good handle on this. I'd like to give you a non-example instead. Make sure that you write non-examples so that you don't go back later and think this is correct. This is not correct. There's a very common mistake that is made in this work. Please pause the video here and see if you can answer for yourself what the common mistake is, and then go ahead and correct it. When you see the mistake, you can write it to the side as a full sentence. Okay, that's right. You've probably noticed that the mistake is in the distribution step on the first line. This negative 2, if it was done correctly, should have been distributed to all 3 pieces. Instead, this person only multiplied it times the first term, forgetting that this x should have turned into a negative 2x, and the negative 3 should have turned into a positive 6. From there, if they had correctly finished the problem, negative 2x and 3x are like terms that combine to positive 1x, and negative 1 and positive 6 combine to positive 5 as the actual constant. Thinking about this common mistake, this is something that everyone will do no matter how good they are at algebra. And so the best way to avoid these details, or avoid making these mistakes, is to think about the mistake as you do the work. Not just what should I do, but what should I not do. Keeping that in mind, please flip to the back again and solve these 4 problems. Pause the video as you do so. When you press play again, I'll show you the answers. Here are the answers for the next 4 practice problems. This is 5 and 7. And 6 and 8. If you need more time looking at these answers, pause the video here. Otherwise, we'll move on to your last example. For the last example, we'll do something a little different, which is we're now going to look at situations where there are multiple variables. In this case, x and y, although we really could have used any letters we wanted. In order to deal with multiple variables, you need to have a really solid understanding of what like terms are. In a case like this, two terms are only alike if they have both the same variables and each variable's exponent is the same. So for example, these terms, well, sure, they have x and y, but the x is squared in the first and cubed in the second, so they're not like terms. All your normal algebra rules apply, so this 2 is going to be distributed in to the second polynomial, and I'll just bring the first one down like it is. And now that I'm done with any grouping symbols, no more parentheses, I can look for like terms. And you got to look a little carefully. Is there any other term with x squared, y squared? No. So there's no like terms, and that one's just going to come straight down. Are there any other terms with x cubed and y? Oh, sure. This one at the end, that's the same. When I combine those two, use the same process. So 3 and negative 10 combine to be negative 7. Keep the variables. Keep the exponents. These final two terms, again, if we do that process of comparison, are still not alike. So those are going to come down just like they are. And this is my final answer. It can't be simplified anymore. Please do write down these reminders in case you need to come back to them on your homework. And then once you've got these, you have two final practice problems for you, which you should do by flipping the page over. Pause the video as you work them out. And when you press play again, I'll show you the answers. The answers for the last two practice problems look like this. There's number 9, and here's number 10.